Okay, let's do a couple videos on solving some of these problems from chapter 6. Here's number 19. 12 Newton horizontal force pushes a block against, that's weighing 5 newtons against a vertical wall. It says the coefficient of static friction and the coefficient of kinetic friction. Assume the block is not moving initially. Will the block move? And then in unit vector notation, what's the force on the block from the wall? So let's start this out how we usually start things out, which is drawing a free body diagram of the block. There's our block. Of course, we're going to have gravity going down, Fg like that. We've got this applied force over here, which we're just going to write as F. There's going to be a normal force pushing in the opposite direction, Fn, and then there's going to be some kind of friction force holding the block up. Now, whether or not these two are balanced is kind of the question. This one and this one we're going to assume are balanced because there's no other forces acting in the side-to-side direction. So how we usually set this up is just to be very formal about it, and we say, let's start out on the x direction, and we'll write F net equals ma, and I'm going to choose the positive direction to the right, so I'll keep this force as positive and this is negative. F minus Fn equals ma. I know that there's no acceleration in this direction, so this is going to be 0. So I know that my normal force has got to equal the applied force up there. So that's kind of the answer to number B up here, or part B. In unit vector notation, what's the force on the block from the wall? Well, it's going to be the exact opposite of what the normal force is, so it's going to be this one over here. Just continuing on, though, in the y direction, we're going to see, first of all, is it possible for these two forces to be balanced or not? So choosing up as positive, I suppose, we're going to get friction force, minus the gravity force is going to equal ma. I guess I should write in the x direction, and back over here I should have written in the y direction. And we're going to see, is it possible for this to equal 0? And the way we're going to see about that is, let's set them equal to 0, and let's see if our friction force can be big enough to counteract gravity. Friction force equals gravity. And we're kind of looking to see, is that possible? For the friction force, that's just going to be mu times the normal force, which is going to be mu times our given force F, since the normal force and F are equal to each other. So let's do some numbers for this now. So our friction force is, we're going to use our static friction, which up here is 0.6. There it is, 0.6. 0.6 times the force that was pushing against the wall. So F is 12 Newton horizontal force. So that's going to be 12. And we're going to see, does this equal the force of gravity, which is the block weighs 5 newtons. So does this equal 5 newtons? So really we're checking if it's greater than or equal to. All right, so kind of no calculator necessary to figure out if it's greater, but 12 times 0.6, 7.2. So it's 7.2 and it's greater than 5 newtons, so we know that it's going to be stationary. And so the block will not move. And then of course the force on the block from the wall is going to be the same as the force that's on the block. What is the force on the block from the wall, right? It's going to be the opposite of this force right here, sort of the opposite of what it's going to be this normal force. So that's it. That's for number 19.